All right, welcome back to Bangalang, back to another coding session. I'm going to continue along here with, we had some features and some cleanup and stuff we wanted to do, so I'm going to continue with those. This is the main, well, this line here is the main thing that I want to tackle today. After a bit more investigation, I think I've discovered that it's actually more of a bug than a lack of a feature. I had been thinking of, plus equals, minus equals, those kinds of operators as binary operators. Bit of tea. But it seems like that was the wrong way to look at them. They're more like assignment operators. So they shouldn't really be here with the rest of my binary operators. They should be up here as alternatives to the, this is like the normal assignment operator, and these are kind of alternatives to it. So let's have a go at moving those, shall we? In the grammar, it shouldn't be so hard to do. I guess we need no, we don't need a question mark. We just have those brackets there so we know we're or in between. So let's grab all of these. Whoops, do a copy. Maybe while I'm here, I'll cut them out of this part. All of the something equals ones. Alrighty, and then we come over here. And we'll cut out the ones that do not have equals. Like so. So then we have plus equals. We've got two ors there. All right. So let's have a look at the grammar now. So here you can see we have a smaller list of binary operators. We just have the non-assignment versions of the arithmetic. And now we have the assignment versions of the arithmetic up here. Perfect. So how do we actually implement that? First thing we're going to need to do is some parsing. So parse assignment is where we want to go. Here's parse assignment. And currently it just looks for the equals token, but it needs to look for more tokens now. So I want to make a list of these tokens. So they're like assignment operator token types, like so. So we have, an asterisk equals. What's wrong with this? What's wrong with this picture? I guess they should be token types. Backslash equals. Let's see if I can remember these in order, alphabetical order. Maybe equals is next. Minus equals, percent equals, plus equals. Backslash. I think that's all of them. 1, 2, 3, 4, 5, 6. I think that's all of them. So these are the assignment operator token types. In my AST lists, I have a bunch of lists here. So maybe I will make these node types, just so we can be clear about what's what. Underscore node type. Like so. Okay, so now we have a list of assignment operators. We can search it and check if we've found an assignment operator. Slice linear search. Oops. assignment operators token types. We need to get the token first, or at least the token type. So that's kind of like that. And if we found an assignment operator, then we can go next token. And the next thing we want to do is create our new node. Because since there was only one kind of assignment before, we didn't need to model that at all in our AST. We just knew it was equals. Now we don't know that. So we need to create a node that will tell us. So what would the type of the node be? Well, I guess it is, we can map it from this. Oh, this takes a whole token. I feel like that's unnecessary. Can we just go like this? So this is our mapping. It already has most of what we're looking for in here, but it doesn't have equals yet, which I guess would go to like assign instead of like add assign. It's a it's a little bit weird at the moment because now we have assign and assignment. Assignment is the statement and assign is the operator. We could probably be more explicit and say, you know, assignment statement and assignment operator. Maybe at some point we'll do that, but not yet. So now this needs the type. All right, so I think that's it. Well, no, actually in parsing there is a little bit more to do. There's these utility procedures which are talking about binary operators, and we need to take out our assignment operators now that we consider them assignment operators. And also from this list here, which is the binary operator list. So that's kind of the same as this, but for binary operator. That's why we put this here, because we already had a binary operators list here. So now this one is distinctly for nodes and this one is for tokens. Again, we can take the assignment operators out. And then, of course, we need to order these things nicely, because otherwise it would just be very sad. So this closing angle bracket should be right up here. And closing angle bracket equals. I have equals exclamation opening. Yeah, I think that's right. And now we can use that in our parsing. We'll just say slice linear search of those. Again, we don't really have to pass the whole token in here. We could have just passed the type, but whatever. And we'll just return that. Okay. Cool. I think that's parsing taken care of. But now that we've added this extra node, that's going to affect a lot of places. For example, if we go to the top here, see this kind of thing. We're specifically looking for the assignment of a type. And we do this to check if there's a right-hand side, which is not valid anymore, because it would have 3 children, not 2, because we have the operator node now. And this would be the third child, not the second. So I think we need to sort of do some search and replace stuff here. So this is for assignment. So actually I'm going to change this to just greater than 1, something a bit more flexible. It's also assignment. This is also assignment stuff. That's type node, type node, type node, type node. And then there is this. Hopefully this will catch all of them. So this one here is obviously assignment stuff. So this needs to be 2. And this is just below it. So the right-hand side node should be 2. This is also assignment stuff. This is type node. It's just, yeah, this looks like assignment as well. Change that to a 2. That's type node stuff. This is a right-hand side node, but it's part of an expression, so that's something different. This is a right, what is this? This is indexing. That's more indexing, more indexing, more indexing. So that's nothing to do with it. Right-hand side node. So this is compound literal stuff. So compound literals are composed of assignments. So that one should be 2. This is array stuff. That's not it. Type node, type node. This here is a procedure, which you can see on the left-hand side. A procedure is actually generated from an assignment of a procedure. So maybe to make it clear, I'll call that the right-hand side. That is a right-hand side node of an assignment. This is if statement. This here is assignment, I'm pretty sure. Yeah, assignment. This is expression. This is like indexing stuff. This is more indexing. This is compound literals again. So this is assignments. And this is more of it, I think. Yeah, it's more compound literal. Type node, type node. What is this? That's conversion call, so that's something else. This is bite-sized stuff, so that's getting a length or something like that. This is also length stuff. Okay, so I think that covers everything. I hope so. We want to add some extra checks because assignment is more complex now. I think we want to do it after we have established what the left-hand side, okay. That's like spelt wrong and in the wrong order. After we've established what this is, maybe this is a good place to do it. Although we do need to know, there needs to be a right-hand side. Otherwise, we don't have an operator node. It just doesn't make sense. And we could use the right-hand side node. Type information. I think that'd be fine. So maybe up here we'll get the operator node. And we'll just say this is the right-hand side type node result, which we'll put in here, and we'll also use that as our type information when we're type checking. So we're going to sort of steal some stuff. Oh, this is exactly right, the place. This is from our expressions, where we limited what kind of expressions we can do with different types. Because that's basically what we're doing here. Because we're moving some of our expression stuff to be assignment stuff. So this type node is this one. We don't allow bools. Yeah, so basically if it's not a numerical type, then it's not valid. We're type checking assignment here. And so these are assignment operators. So if it's not numerical, we can't assign it. So actually, before we go in here, we should say when it's not assigned, because the regular assignment operator can be used for any types, any type. So it's only when we're not dealing with this, then we need to get specific about types. So if it's not a numerical type, then we quit out. I think we can sort of put these with their respective stuff. If it's a float type, modulo is an expression, a binary operator, but modulo assign is an assignment operator, so floats cannot do that. And atomic integer has to be add assign or subtract assign. I think that's legit. But these nodes are the operator node. Yeah, assignment operator. And I think we should also get the type info from those. But the type name should, I guess, come from this. Like so. So I think that's kind of like got everything type checked nicely. And then if we go back, oh, that was good. I got there nicely. So again, we can go like this and bring these down. These need to stay together because it needs to be a bool or a numerical type. But here we can cut out this because that's an assignment operator now. And these are also assignment operators. Oh, did I just noticed they are like a node. Yeah, this node should be the operator node and that one. So now these are ones that these make sense. Cool. I think that's all the type checking. I think generation is where things are going to get a bit hairy. So when we go down to assignment, now the thing is that how we did have it was that in here, when at the end of the expression, it did a copy to some location, which made sense. Which made sense for assignment when the only thing assignment can do was a simple copy. But now that it can do different things, I think it's better if we do this, if we return a location. This one we can call LHS location. We passed in des, didn't we? What was, oh yeah, that was this. Okay. So we'd need to do that. And then, for example, if, well, I guess we need the RHS node and the operator node. We need to know what operator we're talking about. And for example, if it's assign, dot type equals dot assign, then we would do the simple copy like we did before, right? From the right-hand side to the left-hand side, and the type is LHS type node. And here we need to do a bunch of new stuff to handle the other cases. So we need to refactor this. And this here is setting it to doing the nil assignment. So I want to extract this part, which is setting some memory to nil. let's cut that out and do that, and instead of passing a location, we return it. Before I forget, because I have copied something, I better actually extract it. There we go. So we're nullifying, do we need to put the file? Yeah, file. We're nullifying a location. And we need a type node. So here it was doing get type result. Let's see. I don't know if that's really necessary. I guess we'll find out if it's not. We know that we're doing nil stuff, so we can take out these conditions, I think. Go like that. And I guess this would be copying, but I'm a little bit dubious of this. Like, what is the purpose of setting a register to 0? You know, if we want to nullify something, I think the whole idea would be that we need to nullify some memory. Like, I don't get this. I don't think this is really a thing. So I'm going to put this assert here, and we'll see if it ever triggers. Maybe it never happens. Yeah, maybe it never happens. So up here, I'm just going to put that directly in there. So all this does now is provide a context for the expression. That's all this sort of outer expression procedure does. And now we have to fix up all the places that call it. Let's start from the top. So this guy can just go like that. I think we don't need to care about, like, if the whole statement is just an expression, we're not doing anything with the result. Why is that a problem? Oh, it's not. Now we do have to be careful in some places, because the previous way that this worked is it was putting it into a register. Now, when I do this, it's not putting it into a register. It's whatever the result of the expression is. It could be an immediate or memory or whatever. And because it appears on the left-hand side of this compare operation, and we know the right-hand side is an immediate, but this cannot be an immediate. So I'm going to say copy to non-immediate. What does that need? File source number. I guess the source is this, and the number is 0. Is there anything else it needed? A type, which I guess is this type. Like so, and then this would be the location. Cool. I think that should work. We probably have something very similar down here. I might be able to just kind of reuse this, but we have a different node that we're using now. I think that works. and that's expression location. And then in the for loop, we have something very similar. So it would look a lot like this, I guess. One thing we do have to be careful with here is it uses the for context. For context and child node also uses register 0. So then that would be like that. This child node, it is a pointer. So that should be okay, right? What's wrong with that? Probably nothing. Alrighty, what's next? So here, this is the return location. I guess we have an expression location. And then we do a copy from the expression location to the return location. It might be at some point that we can avoid copies like this. Like, yeah, maybe we could pass something in like a desired destination if we wanted to, an optional one. Anyway, let's just, we're doing this now, so let's see. So this here, this is the exit code location. Well, this is the same, isn't it? We could do this up here. But we have different locations. There's the exit code. So I'm going to say exit code, and this one is the syscall number location, which we set to 60. And this one we set to whatever the expression was, like that. Okay. I think that looks pretty good. Let's go to the next one. Lots of errors to do. So this one here, I'm going to leave this as an error, as a reminder that I need to do this. Okay. So now we're indexing. So I guess really this location is going to come from here. And this location is used for comparisons. So we might need to make sure it's in like because this right-hand side could be memory, a memory address, or an immediate. This one should really be a register. So we might have to copy this into a register. Where else is it used? Here, it's on the right-hand side of a move. And here, it's on the right-hand side of subtract. So for those two things, it doesn't really matter what it is. Could be anything. It's only for this bounds checking that we care about it being a register. So what I'm going to do is this. I'm going to copy I'm going to copy it to a register just if we're doing bounds checking. Otherwise, it's not necessary. This is for the end index when we're indexing, and I'm guessing this is going to be pretty similar kind of thing. Yeah, so for bounds checking, we would need to make sure it's in a register. Otherwise, it's just on the right-hand side of a copy. So yeah, same thing. So let's move this here, and this is copy to register. Like so. think that's probably fine. Yeah. Okay. What else we got here? This is the compound literal stuff. So basically we just want to copy the result to there. So we just want to add a copy from the expression location to the member location, and we need a type. I think we also need the type. Yeah, here's the type. So let's go member type node. You can put it there, and well, here actually is we're setting to null, right? This is a nullify. So we're nullifying the member location with the member type node, so we know how big a thing to nullify. All right. Is there something wrong with this, or is it just being dumb? It's just being dumb. Okay, so down here, we basically have the same thing going on. So I think we can just copy paste. I'm not a big fan of how much kind of duplication there is in this area, but just the structure of the code makes it hard to combine. Maybe at some point we'll do it. It needs to be a pointer. Okay, I think that's that part done. This, I've been wanting to tidy up a bit. So first things first, without this location stuff, we just want to evaluate the expression. Then we want to assign the location where we want it to go, which depends on our calling convention. Something like that. We could probably extract this out. Like that. There we go. I just need to assign like that. I think that should take care of that. So we want to copy from here to here, basically. So from the expression location to the param location with the param type node. Why is this still complaining? Okay, it's not. Okay, here we want to have a copy expression location to this guy with a certain type, which is this type, which we can extract just like we did here, like so. I think that should be good. Yep. Okay. Last one on the file. So now we're doing a conversion call. So now param location equals this. And we need to be a bit careful because previously it was getting copied into a register. Now it's not. And because these were the same register, it was being copied into the return location implicitly, and it's not happening anymore. The param location only ever exists on the right-hand side, so those are all good. But we do have this implicit case here where it was a no-op, right? It was a no-op when param location was the same register as this, but that's not always the case now. This could be memory. It could be intermediate. If it is memory or intermediate, then we can just use it. because they don't contain any size information in those locations. So we could use a param location. If it's a register, it should have the same register number as this. Is that guaranteed though? I'm not sure. I'd have to really think it through. Let's assume that it is. If we get some errors at some point, we'll find out that it's not. It would be like logic errors though, so that would be a pain in the ass to debug. But anyway, so I think we're going to say like if param location is not a register, then we'll say return location equals parameter location. Otherwise, we're just going to take this, because if we use this one, it's going to have the wrong size. Registers have the name of the register is different for different sizes. So it kind of implicitly has the size information in it. So we do need to explicitly change to there. Maybe just to be really safe, we can say else if the sizes are different. No, I don't think we need to say if the sizes are different, but what am I trying to say here? If this is a different register to this, then we need to do a copy. So how do we know if they're different registers? I don't know. We'll leave that out for now, but because I'm not sure if that's actually going to be a thing. Okay, let's see. Let's see. So this here is a nullify. Nullify the left-hand side location with that type. And now this to do is the last thing we need to do. And it's going to be kind of like this. Yeah, it's going to be different depending on the type. Although here I'm going to put these at the top and do else if. Because it should only ever go into one. We're not returning, that's why. We need to change it like this. I'm going to make assignment variations. And then we'll put an assert false because we should never go here. Okay. And operand type node is left-hand side type node. I think for these we only need a single type node. We don't need this, and I have a feeling we're not going to need that either. Let's see. If I was overzealous, we can put it back in. And register num. Well, this uses 1. This uses 0. So I guess to avoid conflicts, we should use 2 here. I mean, this location should never be a register on the left-hand side of an expression. Well, this is the right-hand side, so it could be a register. Okay. This one should never be a register. Anyway, we're playing it very safe. So now there should be all these procedures like this. which do our expressions for different types. But some of what we thought were expressions are now actually assignments. So let's make copies of these. And we'll just keep the assignment stuff in these ones, and we'll keep the expression stuff in the other ones. What did I say? We're going to cut out, let's have one type, no context, no allocations. We're on the left-hand side here, so no allocations. Type node, context, like so. Okay. So, comparisons. That's nothing to do with assignment. We only want the assigned variations. Failed to generate an assignment. Maybe we should make these labels. Add assign. So anything else we need to change? Result location is copying it to a register, but why? Because it's floating point, and it's always going to be an assign. Yeah, so we need to copy it into an SSE register so we can do an SSE operation on it and then copy it back to the left-hand side. Okay. And we're not returning anything, right? So just say type node. I think that's it. Okay. Let's move on to the next one. No, none of this stuff. Just this, we're not returning. Make those add assign. There's a type node, but let's see if this stuff makes sense. Like this result location, why is it a register? Oh, and then we just overrode it with left-hand side anyway, so. Just like that. And we put the right-hand side in a register. I guess it needs to be in a register. Okay, I'm okay with that. So here we get rid of comparisons. Got a result location. I'm a bit dubious about that, whether that's really necessary. Let's find out. Yeah, I guess it is because we want to copy to register, which we should cut out these cases. Oops, cutting out the wrong ones. We should cut out these cases. These ones. So result location is left-hand side. It's basically always the case, except for here. Multiply is another one, I think, where we need to do like an intermediary. So we have this result location that we do everything on, and then we move it back to the left-hand side. But that's special for there. Everywhere else we just work directly on the left-hand side, right? And we make sure the right-hand side is in a register. Is that really necessary? Well, the left-hand side might be a memory location, in which case that needs to be a register. I mean, it could be slightly more optimized, but that's fine. That's all good. We don't need to check for that guy because it's not possible here. Type node, and at the end, when we assign our result, we go to left-hand side. And let's put a sign on our labels. Like so. Okay, so I think that's all the assignment stuff done. I want to go down to the other versions. Let's start from the top of them, like a float here, and just strip out these guys because they're not part of expressions anymore. So this stuff here is not required. Yeah, just like that. Let's do the same here. So in this case, it looks like there's no arithmetic we can do. So let's go like this, and we'll just assume that it's a comparison because that's the only possibility. And for signed integers, we'll cut out the assignment variations. So that just does not happen. Like so. Okay. All right. I think we did everything. Let's see what happens. Failed to generate assignment. We're in signed integer. So the node has the wrong type, I guess. It's the assignment node. I think we need the operator node. This is the one we care about. Okay, and now we have a few errors. 707. So this is just before skip main scope. Is that in the for loop? So what is happening is that this expression does not know the size, because this is memory, this is an immediate. So neither of these have any implicit sizing with them. This is the if, so let's say skip ifs, and this is else if scope. Yeah, I think that's a bit more descriptive. So here we need to provide size information. So byte size of, so it's expression size. I guess we could put this here. It's the only thing it's used for. So it's like the expression operation size. And then I guess we need to use it for this other test also. No, we don't need it. Yeah, that's fine. Okay, and probably in the for loop we have something similar where this could be memory. So let's do the same thing. Like that. How does that look? Okay, we're down to 2. 1939. 1939. So we're doing a conversion, and the operation size is not specified. Normally when there's a register involved, you use the size of that. But because this is specifically for moving between registers or locations of 2 different sizes, we don't know the size of this. So if we go to our conversion code, it's this guy. We need to provide a size for the second argument. So it's like the return size. No, parameter size. We'll put that in there. Hey, and now we have little triangles. So that's all working. And my plus equals, minus equals, all that stuff is better, much better now. Awesome. And we're 15 minutes in. We have a little bit of time. Maybe we can pull these off. I think these are not going to be too hard. So let's have a look at the precedents for those. Operator precedents. So and or, they have their own precedences. So this is all the comparison stuff, and then there's and or. And not is not a binary operator, so it doesn't need precedence. So let's, I've kind of, I'm a stickler for ordering. So I've kind of done these in order of like where they appear here. Yeah, so we put them on the end, I guess. No, I haven't done them in that order. I've kind of done it backwards, actually. Yeah, kind of done it backwards. So let's continue the backwardsness. Whoops. So that would be and, that would be or. And then it's in our right-hand side primary. Like we've got negate here. We could also have not. Yeah, so we can say not a right-hand side primary. And now we have or and is in our right-hand side expression as a binary operators. So we need to add to our tokens. I don't think we have just exclamation, do we? No, we need to add that as a new token. Ampersand we don't use at all. Interesting. Ampersand, ampersand. And the other one is pipe, which we haven't used yet either. So it'll be pipe, pipe. So now we have the tokens. We can go into tokenization and add them to our list. So pipe, pipe will be this guy. Oh, these are not in alphabetical order. Ampersand, ampersand is this guy. And what was the other one? Exclamation. Like that. So now we have those tokens getting tokenized. Parsing, I think, yeah, well, first we need to have the precedents. So they have their own precedents, right? 4 and 5. Ah. Ah, so he's going downwards, so that's why I'm a bit confused. So actually they need to go at the top. And pipe, pipe needs to be the first one. And ampersand, ampersand. So this needs to be 1, 2, 3, 4, 5, like that. I think that's the correct way. So then this has the lowest, pipe, pipe has the lowest precedence. Yeah. Yeah, so I've done it kind of backwards compared to him. I only just noticed that. We need to add them to here so that we know that they are binary operators. Ampersand, ampersand, and pipe, pipe. And in here, we need to be able to change them to, so pipe, pipe is OR. Let's put, I'll sort these later. Ampersand, ampersand is and what was the other one? Exclamation is not. So in here we need and or and not. Okay, so I think I don't actually know if we need to have the not in this mapping because it's not a binary operator. This is for binary operators really. Well, and assignment operators, but that still is not one of those either. So I think that should be, no, in our primary, we need to add, so where is it? We have all the sort of prefix stuff. So minus, I think I put it after minus exclamation. So what does exclamation do? And it needs to be only right hand side can be, I don't know, inverted. So we're expecting exclamation. Then we create a not node. Yeah, I think that's basically it. Same as negate. Make a new node that goes in between. Yeah, I think I'm pretty happy with that. I think that's parsing done. So now type checking. When we type check a primary, we can come across a not node. I'm going to put it after negate here. And we have some type checking here. Basically, we need to say, oops, if it's not bool. That's the only thing you can do not with. Cannot invert. I feel like there's maybe a better name for that, but whatever. So that type checks that part, and or are binary operators. So we go up here. And they're only possible with bool. And or. So bool can be one of those. I'm going to say if we get past here and it still says, and we're still trying to do and or, we've established it's not a bool, then we say, no, you can't do that. So you can do it in here, you can't do it anywhere else. I guess we could say like, just like that actually. So it's not a numerical type, or you're trying to do one of those, then yeah, it's no good. Okay, I think that's type checked nicely. Now generation, when we're generating a primary, where's our primary? Like where's our negate? negate. Let's copy that and do, what do we call it, not. So we can only not, there's none of this float business because you can't not a float. Do we need to copy to a register? Well, what do we need to do? I think basically we need to do, I thought about this a bit. I think we can do an XOR with 1. So we know that what's coming in should be a Boolean value. I guess we'll say not immediate, I think should be enough. Because we know this is an immediate on the right-hand side, so non-immediate should be fine here. So XOR means that either it's in this or it's in this. So if this is a 0, then XOR will be like, okay, yeah, exclusive OR. So if they're both 1, the result will be 0. So if that means that if this is a 1, it'll get flipped to a 0, right? But if this is a 0 already, then the exclusive OR will say like, okay, there's a 1 and a 0, that means that the result is 1. If one of these is 1, then the result will be 1. If they're both 1, the result will be 0. So it effectively flips, I think. Let's see what actually happens. Now, if we go into our Boolean operators, and let's see if we can do and or. Are they still comparisons? They're not really comparisons, are they? No, I don't think they are comparisons, which reminds me that there is like a comparison operator list that I guess they should not join. And this is kind of for the comparison operators. So we'll take those out because we don't need to do a compare, I don't think. Yeah. So, so actually, we have these comparison operators, binary operators. We should add it to that. Oh, we should take these out. They are not binary operators. We don't have so much time, so I'm not going to bother with alphabetical ordering right now. So in that case, we return. Otherwise, we do and or, which I think there's. I haven't looked this up yet, but I'm guessing there's an and, right? Yeah, logical and. Which looks pretty standard, and then there's probably an or. Or. And because we know we're dealing with Booleans that only have 1 bit set, should be fine. %s and or. So this is the RHS location, and the result location, what is that? It's a register. Yeah, that makes sense actually. So I think this LHS register location is what we should put here. Is it? The result location. I feel like we do things a bit differently. And this is actually the result. Oops. Result location. So this result location, I feel like because what I'm trying to do here is I don't want to mess with this left-hand side location. So I think we need to copy it somewhere else and then use that. I think that's right. So then if we say, well, one place where we can test it that's in real code is in the standard library. Oh, we should be able to take these brackets out too. Let's just test that that works. Yeah. Cool. And the one place in the standard library that we can test, there's a loop somewhere that's kind of annoyingly nested. Where is it? Here it is. That should be like that. And the FPS should be about the same. Looks good. So if we go here and we do and, we're ANDing R12 and R11. And then we're testing. So R11B was set up here, R12B. So interesting that we don't move it into a new, we don't copy it into a new location. Actually, I think I remember in other places, like down here maybe, I'm sure there were some examples. Yeah, so for right-hand side, we do a +1. But for result locations, we just do register num. Well, I guess if it's a register, it's just a temporary thing anyway, and it should be fine. Yeah. Okay, so maybe we just add a couple of tests because we are rigorous testers, and then we should be done. So I guess we go up like equal, not equal, and or. So let's go var1. Well, I guess it would be like this actually, because var1 is, I mean, if we go value 0, we could do that. Like that. And then or, we do like this, and we say or well, actually, I guess we should say value 1, and then we should say that and that is good, that and that equals false. And that is all good. Yeah, but when we do or, 0 and 0 together. Wait, so value 0 in our tests of Booleans is true. So I think for the and, if that's true and true, yeah, true and false is false, and false is false. For or, that's true and true is true, true and false is true, false and false is false. Okay. And when we have negate, we can put not after that. And we can say not var 0 equals false, and not var 1 equals true. So it should just flip. We'll put equals equals. And then we need to restrict it so that only Booleans try to do those tests. So it's in the value tests. Or there's general tests, value tests. There are bool tests. So we should probably add them to the bool tests. Where's our bool tests? Oh, they're just in value tests. But isn't this doing it for bool? I'm a bit confused here. No, there is a list of bool tests. It's above numerical tests, which is where I've put them for some reason, even though they're totally not numerical. So I put them with bool tests, and or not. Okay. Rename the tests and cross our fingers. Cannot refine type of undocumented code. That's legit. You shouldn't be doing that. Okay, fingers crossed that this works because we're about ready to finish. Nice though that we actually did tests. I'm a little bit confident because it's going so long. No, damn it. Okay. So test line 12 XOR. Yeah, so we need a size. So it's always going to be byte, the size. So that makes things easy. What's line 27? That's XOR as well. But I'm guessing maybe all of these need to have the size. So where we want to look. And our Boolean stuff. So and let's go byte, and then so not is in primary. Where is it? Here it is. That's our XOR. So let's try that. I'm actually just starting to think, like, is this necessary? result location is a register. So I think that's actually not necessary there. We've got an assertion failed. Okay. So it's just the and that failed. It was just, and it looks like it was just a single assertion. So let's check. Maybe we wrote the test wrong. So, and this is true, this is false. So true and true. Ah, it could be the precedence. This has a lower precedence than this. So we might actually have to do this. It's the first time I've come across that. If we go parsing, so that has a lower precedence than that. So it would evaluate the equals equals first. Fingers crossed this time. We really need to do something about speeding up our tests. It does not make me want to do, yeah, all right. That was it. Great. So that is definitely enough for today. We've got all of our assignment operators working, and we got these. So cut out that chunk. Awesome. Thanks for stopping by. Have a good one. Ciao for now.